Hello students, welcome to the Master School Foundation program. Today we are going to deal the very important topic, that is sign convention and lens maker's formula. It's very clear, we would like to know about that. Yeah, while you are going to get that, the sign indicates yes, we would like to talk about that direction, and we would like to talk about that nature of image, right? So it indicates direction. It's a symbol, just you have to get that conveys message, conveys information. Yes, sign, does it conveys the information regarding to that the image distance. Okay, it's very clear, we would like to go for that sign convention, that information which was conveyed traditionally, just we have to get that conventional, that is going to be the traditional method what we are following. So while you are going to get that measurement of the image distance, so you know very well about that the image which has been formed due to the reflection of light rays and also the refraction of light rays. While we are going to considering that single curved refracting surface, reflecting surface, either it is going to be getting the double refracting surface, it is going to be lens. Just we would like to talk about that either in case of lenses, either in case of the curved mirrors. The sign convention plays important role which can decides. By knowing that sign convention, we can decide that is going to be the virtual image or real image, or in what direction does it is going to form the image. It's very clear. But you need to take that coordinate system. It's very clear. System. Yes, where you are going to place the object. If you have been placed the object from a one reference point, you can measure the distance. Okay, all measurements are going to be taken from a fixed point. Let's have that. Yeah, if you are going to get that pole, yeah, in case of spherical mirrors, we would like to get this from the pole, right? Okay. Optic center, we would like to get that. Yes, that is in case of the lenses, we are going to get that lenses, right? That is very clear, we would like to go for that. From a fixed point, we are going to take the measurements. It's very clear. Yeah. So if you are going to measure that, yes, yeah, length, height, length of image, height of image, you are going to get that. So axial, we would like to go for that vertical distance, axial distance, just we are going to get this one. Longitudinal and lateral, we would like to take up that longitudinal distance, lateral distance, just we have to get that. Length of image along x axis, just we would like to go for that. So we would like to get the measurement height of the image. While you are going to get that, this is going to be taking with respect to, just we would like to go for this. We are going to take that height of image. Yeah, it's going to be getting that. This is the height. So we can measure with respect to that principal axis. Yes, perpendicular distance, that gives the perpendicular distance. We are going to get that horizontal distance. From a fixed point. Okay, that fixed point is going to be the pole in case of the spherical mirrors. So in case of the lenses, we are going to take that optic center. That's very clear. It's very easy. If you are moving in perpendicular direction, yeah, if you are going to move in a perpendicular direction, just we have to see. It's very clear. So above the perpendicular, above the principal axis, yeah, this is going to be the principal axis, it's going to be positive. Below the principal axis, the vertical distance, it's going to be height of the image, it's going to be negative. Just we have to take that below the principal axis, above the principal axis. Just we have to take that. Generally we are going to get that these two measurements are going to give that nature of image. Whether it is going to be above or below, just it is going to convey inverted, erect, inverted, virtual, real, all about to know that measurement. And it is depending on the sign convention also, how we are going to take the measurements. Okay, let's have the look into that matter. Even though we would like to show the direction of incident light and all, yes. It's very clear. The following conventions of the science is the adopted for obtaining the relations between these quantities. Let's have a look. Just we would like to get the direction of light incident, just we would like to go for it. While you are going to have the idea about the sign convention, you need to get that coordinate system. Yeah, we are going to get that vertical. So this is going to be the x and this is going to be the, let's assume this is origin. Yes, while you are measuring that horizontal distance, just we have to take that, these are all going to be positive, these are all going to be negative, these are all going to be positive, these are all negative. It's very clear. Yeah, even though if you are going to take that vertical distance above the principal axis, below the principal axis, that is going to be, vertical distance is going to be positive, negative, here. It's going to be object distance is going to be negative, image distance is positive. All that depends on that type of the mirror or type of the lens what we are using to track the image, and also the position of image, where does it forms, it conveys the information about the type of image. Yes, it's very clear. We would like to go for this one. You have to adopt this coordinate system to have the measurements. It's very clear. Yes, light is going to be incidental left to right. Just we are going to get this one. This is the direction of incident light. That is incident light. Yes. So you are going to get that in this opposite direction, we are going to get that negative. So it's going to be positive. Just we would like to see. While you are going to get this one, we would like to get, yeah. Yes, already we have discussed that sign convention. in concave and convex mirror, but we would like to extend the topic to the lenses. It's very clear. Okay, yeah, we would like to go for that. Yes, let's assume this is going to be the object. Yeah, image. Yes, let's assume. Yes, we have seen like that. That is the direction of incident light. Okay, we are all about to know this is O is going to be the center, optic center, just we have to see. Yeah, the original meaning of that x dash and y dash, they are going to represent that vertical and horizontal axis. They will meet that their intersecting point is going to be O. It's going to be the center of that lens, optic center. Just we would like this one. So let's assume this is the object we are going to consider. Okay, if we assume this is going to be the image, right? Yes, we would like to go for this one. Yeah. Generally, what's the phenomenon that we have been observed? The incident light which refracts and cuts the principal axis. Yes, you would like to go for this one. Very clear. Okay, right. Yeah, this is going to be the direction of incident light. From the object they have been started, we are going to take in that from the object they have been started and they will form just, okay, we would like to consider this. Yeah, for the incident light further proceeds and get the refraction. After the refraction, they will meet the principal axis at this point and they will meet in the correct place. Okay, it's very clear. On either side of that lens, sometimes you will get that the rays are going to be originated from here. Yes, that time you will get that image distance is going to be negative. It's very clear. It has been seen. Let's go for that. Okay, all right. Let us have the look into that matter. Please have the look. Axial distance. It's very clear. Distance above the axis. Yeah, it's very clear. We would like to go for that. Linear lateral, just which is going to get that perpendicular distance, lateral distance, linear, longitudinal magnification. While you are talking about that longitudinal magnification, we are going to get that sometimes while you are talking about that dimensions of the object and the dimensions of the image. So the size of object is going to be different. Yeah, as compared to its length and breadth, length is going to be the very small. Yes, we would like to go for that. No, its height is going to be considered. We would like to go for that, the measurements which are going to be perpendicular distance above the principal axis. All right, it's very clear. So we would like to get that lateral magnification. And we would like to get that linear magnification. That is very clear. Even though in all the cases we would like to take the measurements based on the sign convention from that point above the principal axis, that is perpendicular distance above the principal axis or below the principal axis, which is going to be positive. This is positive. This is going to be the negative. It's very clear. So the cases are different. All are depending on the dimensions of the object. Yes, depending on the dimensions of the object, we will get that image dimensions also, whether it is going to be magnified or diminished, it's all right. Yes, but we should take the measurements and the sign convention according to the coordinate system. All right, it's very clear. Let's have the look into that positive axial distance, negative axial distance. It's very clear. Okay, we would like to go for this OP, which is going to be positive, which is going to be negative. Let's have a look into that matter. Yeah, OP and OA. Yeah, you can take that. This is going to be positive. Yes. Yes, you will like to go for this one. This is positive. This is negative. Okay, all right. Yeah. right hand side and left hand side is going to be according to the coordinate system. Okay, right. So we can take that OQ is equal to is positive. Here OA is negative. Okay. Yeah, AB is positive. AB is positive. PQ is negative. Yeah, sorry, just we have to get this one. AB is going to be above the principal axis, it's going to be positive. It's very clear, all right. Nothing to worry, just it's going to be positive. PQ it's going to be is negative. Very clear. We would like to go for all these measurements, right? Okay. Yeah, sometimes we are going to get this one. This is going to be the position of yeah, we are all going to get this one. It's very clear. This is object, this is image. While you are going to get that dimensions of that object, we will get that measurement of that image along that axial distance. We would like to go for that along x-axis, along y-axis. For what we would like to go for a x-axis and y-axis, we have to think. This is very clear. All right. Okay, let's go for that. Yes, the distances are measured by taking the optical center, that optical center of the lens as the origin. It's very clear. So, the optical center should coincide with the origin of the coordinate axis. That's very clear. Generally, if you are going to take that, where that coordinate axis, that means you can confirm that that is going to be the origin. It's very clear. Yeah. Yes. The optical center of that axis is going to be we have to consider this is going to be the origin. Yes, all the measurements are going to be taken from this one. It's very clear. That's what we would like to go for that. The direction of incident light, it is going to be positive. Opposite to the direction of incident light, that is going to be the negative. Just we have to consider. Okay, the distances are measured by taking the optical center of the lens as the origin. It's very clear that what we are going to have that. Okay, let's have the look. Right. Yes, what about that next point we have to consider? Well, we are talking about the direction of incident light. So, the distances measured in the direction of incident light are considered or positive, all right. But while in the opposite direction to the incident light, yes, those are measured in the direction of opposite to the incident light, they are going to be taken as a negative in this direction. You are going to get that. Generally, we are going to take that the direction of incident light from left to right, just as usually. So, they are the light rays, the incident light rays are going to be initiated from that object. They are going to be started from that object. After that refraction, they are going to be form the image. Whether it is going to be the real image, where that they will cut in the real, they will meet the principal axis in the real space. But it's going to be that real image, right? While those measure in the direction of opposite to the incident light, they are going to be taken as the negative. It's very clear how we are going to decide which is going to be that positive, which is negative, right? Based on the direction of incident light. In sometimes it appeared to be originated from that point. It is going to meet that point, actually meets that point. It appears to be originated from that point, even though that refracted light ray. Yes, you have to consider that is the that decides the nature of image. Okay. So finally, we will get that positive and negative. The distances are going to be getting that based on the incident light direction. Okay, let's go for another one. Yeah, let's have a look into that matter. The heights measured upward and perpendicular to the principal axis are taken as positive. It's very clear. Downward the principal axis, what we are having that. Okay, it's very clear. We would like to go for that. This is the principal axis. Especially we are getting that the height of the object and the height of the image, we are going to get that as per the dimensions. The height is going to be more as compared to that width. Yeah, as it's going to be that thin. We would like to go talk, and we are going to measure that above the principal axis. Yes, we would like to get this one. This is going to be that below the principal axis. So depending on that position of, depending on the position, it's going to be that its magnitude is going to be the high or low. It's very clear, but it is going to be the positive or negative above the principal axis. That is going to be the perpendicular distance above the principal axis is going to be positive. It's very clear. Below the principal axis, that related to the image generally, they are going to be that more, they are taken as negative. It's very clear. But based on the magnitude, sometimes it is going to be high and low than the original. It's very clear. So this is the principal axis. Above and below, we are going to get that positive and negative. It's very clear. Okay, let's go for another one. Yeah, the angle made by the ray with the principal axis are taken to be positive. They are, the ray has to be rotated in anti-clockwise to become the coincident with the axis. Otherwise, it is negative. It is very clear. We would like to go for that angle also, the principal axis. Yeah, we are going to get that clockwise and anti-clockwise. We have to get the direction, right? Okay, let's go for that lens maker's formula, right? So in order to overcome the difficulties in the vision, eye vision, so the defects in the vision, that eye vision, they are going to be corrected by making that lens which are suitable for their eyesight. Just you have to get that. So normally while you are trying to read that letters, now while you are going to see the objects, yeah, you might be having the difficulties. All these are going to be eliminated by adapting the suitable well crafted lenses which are going to making about their focal length and all. Just we have to replace it. Yes. Yes, if it is going to be having that normal presence of the sight, it's okay. Otherwise, it is going to be increased. You have to get that correction by having the suitable lenses. Okay, we would like to go for that. Lens maker's formula. Based on that formula, they are going to craft that lenses. All right. So the type of lens, that depends on that requirement. It's very clear. Okay, yeah, let's have the look into that matter, all of you. Everyone has to look into that matter. Please go for this one, right? Yes, let's have a look into that matter. We would like to go for this lens. Okay, yeah, we are going to take that the incident light is going to be in this direction. Yeah, they are going to be taken as that U and V. Yes, yeah, object distance and image distance, just they are going to get this one. All right, it's going to be compared, that human eye is going to be compared with that lens what we are having this one. Yes, so it will reflect that image. Yeah, it's going to be having that mapping to identify that image of an object. If it is any defect, it is going to be corrected by that lens wearing the spectacles. Okay, it's very clear. You would like to go for that u, it's going to be that object distance, v, it's going to be that image distance. It's very clear. You are having the two curved surfaces, after that refraction it forms that image. It's very clear. So let's have that radii of curvature R1 and R2. It's very clear. So you will get that refraction of here and here also. Just that the image which has been formed due to the refraction of the light ray, which is going to be the object for that second surface. It's very clear. Let's have a look. Consider, we would like to talk about this one. Everybody has to look. Consider an object O placed at a distance u from the convex lens as shown in the figure. Alright, it's very clear. Let its image I, yes, everyone has to get this one. It's going to be object. Yes, it's going to be the object, right? Okay, it's image I. Yes, we would like to go for that image. After the two refraction from the two curved surfaces, just you have to get this one. All right. Okay. Let its image I, which is going to be here, right? After the two refractions from the spherical surfaces of the radii R1 and R2. Here also we would like to go for that R1, which is going to be getting the direction of incident light. These measurements are going to be positive, just we have to get this one. These are going to be getting that. R1 is going to be positive, R2 is going to be negative as per the sign convention what we have discussed. It's very clear. So we are going to be convey that R1 is positive, R2 is going to be negative. Okay, it's very clear. Yeah. Let's have the look into that matter. At a distance v from that lens, image, the position of image is going to be identified. Very clear. So it is evident that u is going to be the object distance, v is going to be the image distance. So while you are going to have the look into that matter, let's have the look. V1 be the, we have to imagine that V1 be the distance of image formed by the refraction from the refracting surface of radius R1. Right. Okay, we would like to go for this one. The refracted ray which is going to be cuts the principal axis at this point, which forms that image at a distance of V1. So again it is going to be acted as that. Let us have the look. It is important for you. This image which is going to be acting as an object for that second curved surface. Very clear, right? So that you have to confirm, you have to consider this image, how it is going to be object for that second curved surfaces. All right, that's what we would like to go for this one. All right. Yeah. Very clear, this is act as an object for the second surface, which is going to be that this is the second surface. Yes. All right. We would like to go for that. Okay, all of you, just you have to go for this one and have the look. Yeah, we would like to go for that animation. Everybody has to see. Yeah, it's going to be that convex lens. Let's have the look. All right. Yes, that is going to be the incident light ray. All right. It has been refracted. Okay, we would like to go for that radii of curvature R1 and R2. Yeah, it's going to be getting that. Yeah. So this is C1 is going to be the center of curvature. It is going to be having that imagined. So it's very clear, we would like to go for this one. In order to have the geometric relations, you need to get that imagined sphere. It's very clear, that's what we would like to go for this one. At the same time, it's going to be like that. Generally, we are going to have that. Already you are all having that this information with you, it's okay. But you need to consider C1, it's going to be the center of curvature. It's very clear, we would like to get that. As compared to R1 and R2, it's very clear. as compared to R1 and R2, it's going to be very less. Yeah, you would like to go for the distance separation between the two curved surfaces is going to be very less. Yes, as compared to R1 and R2. Yes, and we would like to consider all the paraxial rays. Yeah, we are not at all going to consider the marginal rays. While you are going to obtain that expression for the lens maker formula, we have to get the consideration that is going to be that marginal, that is going to be getting that paraxial rays. We would like to consider these rays only. All right. So, that separation which is going to be less as compared to R1 and R2, right, that you would get this separation that is going to be x1 and x2, both are going to be very less as compared to R1, R2, just yeah, they are going to be less than that, no? We have to get, if you imagine this is going to be yeah x1 and x2, just we have to see. All right, this is only one consideration. Okay, let's have a look. Yes, everybody has to see. Okay, you have to get this one image, object and image, it's going to be getting that mu2 1 mu2. Yes, this is going to be that object, very clear. This is going to be that image. We have to consider this one. We would like to go for that mu1 and mu2. mu1 and mu2. This is going to be the refractive index. Refractive index of a rarer medium. Yes, this is going to be the refractive index of denser medium. Denser, that is going to be the lens, what we are going to get that. It's going to be glass, just we are going to get that mu2, it's going to be that Ri of glass material. Generally we are using that Crookes glass and different combinations we are going to made up of that lenses. Okay, usually we used to take that 1.5, it's okay, it's very clear. Now we are all having that explanation about all these things, C1, C2, R1, R2 and mu1 and mu2, it's very clear. Now it is time to apply that Snell's law and get that yes, just you have to see U and V, it is all about representation. So we would like to get that in the direction of incident light, it's going to be positive, but in the direction opposite to that incident, that is going to be negative. It's very clear, it's going to be negative, very clear. So we are all going to have that relation, single, you are all having that relation what we have discussed in the previous classes, right? That's going to be U and V, you have to get that relation that is going to be obtained from the previous classes. Yes, that gives the relation between image and object distance and the R value. That is for single curved refracting surface. Just we have to get this one, refracting surface. Okay, let's have a look into that matter. Yes, that's what we have to get that twice. Yes. Okay, I would like to go for this one, right? Let's have that. Yes, we would like to go for that V1. It's going to be the image distance which is formed due to the refraction of light rays by the first refracting surface. It's very clear. It is going to be acting, yes, it's going to be acting as an object for the second refracting surface, curved refracting surface. Let's see that. This is going to be the first one. All right. Okay, this is also very clear. I would like to go for this one. Right, let's go for another equation, right? We would like to go for this one, that is mu 1 by V minus mu 2 by, yeah. Yes, we would like to go for this one. This is very clear, right? Yeah, depending on that u and v, we have to consider this, which is going to be acting as an object for the second refracting surface. So, right, let's have the look into that matter. We would like to solve the problem, yes, by adding this equation 1 and 2. All right, what we are having that this is going to be the equation 1. Let's see that this is equation number 1. We would like to go for that, right? Yes, it's very clear. Mu 2 by V1 minus mu 1 by u is equal to mu 2 minus mu 1 by r. It's very clear. We would like to, this is equation number 1. We would like to get this one. Okay, so we have to go for this one. Everyone has to look into that matter. Yes, everybody has to see. By adding this, this is equation number 1, we would like to get this one. Yes, by adding this equation, yeah, we have to get this one. Okay, right. Adding these equations, we can solve that. This is going to be R1. Right. Yeah, we are all going to get this one. This is equation number 3. All right. Yeah, after getting that, if you are going to talk about this thing, it's going to be equal to that 1 by f, right? So, we would like to get this one. This expression relates that image distance of V of the image formed by the thin lens, right, to the object distance u and to the thin lens properties. Yeah, it's very clear. It is valid for, yeah, what we are going to getting that. It is valid only for paraxial rays and only when the lens thickness is much less than that R1 and R2. It's very clear, lens thickness is going to be the less than that of R1 and R2, radii of curvature. It's very clear. Now, you can get this one. You know, generally if you are going to get this one, this is going to be 1. Okay, this is going to be equal to 1 by f, what we are having. So, finally, we are going to get that 1 by f is equal to mu by 1 minus 1 and 1 by R1 minus 1 by R2. This is going to be the expression for that lens maker's formula. Let's have a look into that matter. Yes. So, what we are going to see this one, right? The focal length f of a thin lens is the image distance that corresponds to an object is at infinity. Yes. So, you have to consider u is going to be that infinity. From where that light rays are going to be originated from somewhere else, we have to get that object, the presence of object is going to be at infinity. They are going to be originated at somewhere else. So, we would like to go for that u is going to be infinity and v is going to be that image is going to be formed at f only. We have to get this in the above equation. All right. Let's have the look into that matter. All right. If the refractive index of the material of the lens is going to be mu, all right, it is placed in the air, all right. So, that equation is going to be having the form, very clear, right. That gives the lens maker's formula, right. Yes, this is that lens maker's formula. All right, everyone has to see this one, what we are going to be considered. Okay, we have to look into that matter. Just you have to see. Yes, this is going to be the lens maker formula, and you will get that lens formula also. right. Yes, combining that equation, so we'll get that. Okay. So in the coming classes also we would like to discuss about that problems based on this formula, right? Thank you very much. Have a nice day.